Okay. Can hear? Those that cannot hear, you please join again. Okay. Google Classroom, I can, but okay, y'all can go hang out or not? My laptop, my Google got problem now. Ay. It's not kind of problem. Please wait a while. My Google got problem now.
Teacher, I can finally hear you already.
Can I?
Yeah.
So all can already. So then we. Okay. So we stick to Zoom. Okay, we stick to Zoom, ah.
Teacher, can
Yes.
you say the headings, the title just now again, because I was copying halfway then teacher off the meeting already.
Okay, can.
Teacher, so we don't have to write 2.4 and 2.5 yet?
No need. You continue from where you stop can already. Continue from where you stop. For the chapter 2, I will continue to teach. Okay? When the school reopen.
Okay.
Yes, Sophia? Use a new page for your chapter 4. New page for your chapter 4.
Teacher, so index write today's date, huh?
Yes. So the index is today's date, ah? So there are 24 of you here already. I think I will start. Okay, so So today I think I will try to finish, okay, 2 subtopic for chapter 4, okay. So it will be 4.1 and 4.2. Okay, so this chapter is about heat, okay. So heat is what we have known, okay, heat where you can feel in the environment, okay. And heat, okay, usually, okay, we will feel hot, okay, or maybe we will feel cold. Why is it so? Because there is a transfer of heat, and also it will help cause the increase in temperature or decrease in temperature. So today we will learn 2 things. One is the thermal equilibrium, and one it will be specific heat capacity. Okay, shall we start? Start ready, huh? Okay, so heat. Okay, so first we will learn about thermal equilibrium. Okay, before we talk about thermal equilibrium, okay, so what we will do is, where? Hi. Nah, anyways, goes. Okay. So, okay, this slideshow, you can refer to what I have sent you in the Google Classroom, okay, the 4.1 and 4.2. Okay, I have updated the latest one. You can use that as a reference, okay, while I'm teaching here. Okay, if not, you can follow with what I'm doing here. Okay. Okay, so before we learn about temperature and heat, okay, before we learn about thermal equilibrium, let us look at what is temperature and heat. Okay, so temperature is a base quantity. And what is the definition of temperature? Is the degree of hotness of an object. Means that it will measure how hot is an object. Okay, so the SI unit for temperature is Kelvin or degree Celsius. Okay, the temperature, which is measured in Kelvin, we will call it as absolute temperature. Okay, if let's say a temperature is given in degrees Celsius, we want to change it into Kelvin. How we can do it? We can do it by adding 273. Okay, so for example, if let's say you are given 31 degrees Celsius, okay, you want to change it into Kelvin by how? Plus 273. Then it will be equals to what? Hello, girl?
286.
286 man? Plus 31 plus 273 wo.
Oh, 31. I thought 13. 31 plus is 3, 1, 1.
Sakai you 304 lah.
No. 304.
Yes.
304.
304. But this one
I
is
didn't use
measured is
calculator.
your
Sorry,
head
teacher.
lah. But that one is measured in Kelvin. Okay, so same
Yes.
thing. If let's say you want to use Kelvin converted back into degrees Celsius, what you need to do?
Minus.
Minus what?
273.
Correct.
273.
Minus 273. Very good. You see, this class is so interesting. Okay, right?
Yes, very
So,
interesting.
please write down 4.1 thermal equilibrium. Okay, 4.1 thermal equilibrium. Okay, I want you to copy down this one, temperature and heat. Okay, you just copy this one. Okay. Copy this one, number 2. Number 2. The one I highlighted in yellow, please copy down. Okay, including with the box. Faham, girls?
So where you show your things?
I didn't show you,
Teacher,
man. You didn't see me.
teacher, I cannot see.
Sabar,
Teacher, I
sabar.
cannot see the one, the little highlighted one.
Sabar.
See your face. What do you mean you highlight?
Yeah, where?
Boleh. Sekarang boleh?
Okay.
Yeah.
Cannot, teacher.
Cannot, man.
Wait, teacher,
Wait, ah.
Teacher, what happened? Why you do that?
Megan, don't shout.
Why cannot?
Teacher, quiet lah.
Yeah lah, yo. Please. Okay, like this better?
Teacher say just take the
Huh?
highlighted one.
Yes! Alicia!
Oh, teacher, the red color highlight one.
Allow you all didn't listen to teacher one lah. Cry,
Yellow.
teacher cry.
Walao
You only
eh!
siao one lah. You only dumb one lah. Just
Wait.
quarantine
Who ah? Who ah?
keep quiet.
Yes, keep quiet, please.
Teacher,
Your
red
phone want to
color or
spoil
yellow
already.
color?
Yellow
I
color.
only have red
highlighted
color.
yellow color here.
I have red only. I don't have yellow here.
Who wrote that?
Everyone can see my screen ah.
Can.
Hey, hello girl, please don't draw my screen ah. Who ah? Enough ah.
We can see, teacher.
Thank you. Iklima. Wait. Please.
Teacher, wait.
Stop it. If not. Okay, good. Like, yes. Why? Any questions here? So this
I
one
want
you
to
need
copy.
to. Huh?
I want to copy now.
You copy now. You copy now. Yes, Melody, yo. Highlight copy the highlighter one only.
Teacher.
Okay.
Actually, you guys can take screenshot. What? Just take screenshot and copy later lah.
Never mind.
Oh,
it's
yeah.
Okay. Sabar ya, sabar ya.
Teacher, can I just copy? Can I just like directly copy from the notes since we start at 2.3?
Huh?
She said already just now. Just continue chapter 4 in a new page.
Yeah, start new page, copy the highlighted one.
Okay.
Emily, I love you.
Okay, like everyone mute your mic now. Listen, let me talk can already, everyone. Mute. When I say you can talk, then only you talk, huh? Thank you very much. Okay, so just copy the yellow highlighter with the square there. Okay, the red square with the temperature in Kelvin and the temperature in degrees Celsius. This one you must know, okay, because sometimes the question will give you in degrees Celsius. But in this chapter, when they talk about absolute temperature, which means that they want your answer in Kelvin, okay, the temperature in Kelvin. So what you need to do is you must add 273 for your answer, okay? Clear? Just chat there, say okay if let's say you are clear. No one want to hear me. Oh, okay, thank you, Alia. Okay, good. Okay.
Okay.
So, done? Can I continue?
No, teacher.
Okay.
Teacher, it's okay. Just ask them to screenshot only. Then they can copy.
Never mind, it's okay. I can wait.
Alicia, don't be so inconsiderate.
Ayo, okay, enough. Okay. Everyone, listen to me. I say can.
Teacher.
I say cannot. Yeah. Sophia.
Teacher, red
Yeah.
box is under the point 3 or another point.
Point three.
Okay, thank you.
Good. Okay.
Teacher, you already sent in Google Classroom, right? Just ask
Yes.
them to refer there.
Why?
Can
Never
just
lah.
ask them to refer there.
Why you stay at home too long already ma? I want you to enjoy this class ma, together with me ma. Then you can copy the notes slow. If not, how to spend your time leh? You want to spend your time yourself, is it? Okay lo, then I continue lo, okay?
Teacher, don't. Teacher, don't.
Teacher, it's okay, it's okay.
I'm helping you to spend your time, you
Teacher,
know.
don't. My cat keeps disturbing me.
Ask her to go out lah.
Then kill the cat lah.
Nah, I get okay,
Guys, talk about physics lah.
Thank you. Okay, like next
Teacher, I have a question.
Yes.
So temperature in Kelvin is absolute or degree Celsius is absolute?
Temperature in Kelvin is absolute. Okay. Any temperature is measured in Kelvin, we will call it as absolute temperature. Okay?
Okay.
Good. So now next. Okay, next, heat. Heat is a form of energy. Okay? So you can see the difference between temperature and heat. Temperature is a measurement. Heat is a kind of energy. Okay? So when the body is heated, it will receive the energy. It will receive the heat energy. And what happens is the temperature will increase. Okay? But once the object is cooled down, what happens is it is releasing the heat energy, lose the heat energy, therefore the temperature will drop. Okay? So you can see the relationship between heat and temperature. You gain heat, temperature will increase. Okay? You lose heat, temperature will reduce. Yes?
Teacher, in exam we write when an object absorbs heat, the temperature increases. Then an object releases heat, the temperature decreases.
Yes, correct. I mean you mean for definition of heat, is it?
No, just the concept.
Concept, yes, correct. Okay, so this one, the one I highlighted is the notes number 4. Okay, notes number 4. Okay, while you are copying, you can listen to me lah, Okay, so the increased temperature of the object will depend on the degree of which the object is heated, which means that how much heat has been given to the object. Okay, if let's say more heat, the temperature will increase more. If let's say less heat, the temperature will increase lesser. Okay, then the type of material. So if let's say you are using aluminium, okay, and a plastic, okay. Okay, never mind. An aluminium and copper. Which one it will heat faster? The answer it will be
copper.
Copper.
Yes, correct. Copper will heat faster. So different material and quantity of heat. So which means that if let's say more heat given, it will be hotter like that, Okay. So done already, Can everyone?
Teacher.
Yes.
Class is until what time?
Huh?
Class is until what time?
Until 3:30 or 4.
Oh, okay.
Okay. Depends
Teacher,
on how
so copy the
yellow one will do.
copy the Okay.
Teacher, 4 o'clock we got MS.
Why you all MS like to use the same
Teacher,
day with me?
but at Max is not the live one.
Okay.
Aina, I'm gonna kill you.
Okay, maybe I will finish at 3:45 lah, Okay, so look at here, Okay, so now we will enter the important part already. Thermal equilibrium. Thermal equilibrium, Okay, so this is 2 objects. Okay, a cat and a rabbit. Okay, so these 2 objects, okay, when they are like this, they are contacting with each other. We will call this as thermal contact. Okay, thermal contact. So what happens is, if let's say these 2 objects that is heat, okay, they will transfer heat to each other. Okay, so this is what we call it as, okay, see here, can see my video, my screen or not, everyone?
Can.
Yeah.
Yes.
Wait,
Yes.
Okay. Okay, so okay, so you see this is cat. Okay, cat, hot cat, hot cat. Okay, so this is a cold rabbit. Okay, cold rabbit. Okay, so this hot cat is very hot. this cold rabbit is very cold. Okay, so when they meet each other, okay, they will have thermal contact. Thermal contact. So what happens in thermal contact is, okay, there will be transferring of heat. So which one you think there will be transfer of heat? The hot cat to the cold rabbit or the cold rabbit to the hot cat?
The hot cat. The rabbit.
Okay.
Hot cat.
I think both.
Yes, actually, both also will have transfer of heat. But hot cat will transfer more heat to the cold rabbit. At the same time, cold rabbit got transfer heat also, but it will be lesser. So which means that there is a net transfer of heat from the hot cat to the cold rabbit, because this one is more already, the transfer of heat will be more. Okay, it will transfer of heat until you reach a certain, certain situation. We will call it as thermal equilibrium. Okay? Thermal equilibrium, which means that some of the heat has been transferred from hot cat to the cold rabbit. So the cold rabbit will become warmer and warmer already. At the same time, the cold cat will become cooler already. So until a certain part, they have reached thermal equilibrium. So when they reach thermal equilibrium already, okay, so the transfer of heat from hot cat to the cold rabbit and the transfer of heat from cold rabbit to the hot cat will become the same already. So that's why we will say that there is no net transfer of heat between these two objects. Okay, so thermal equilibrium is achieved when there is no net of transfer of heat. Okay, when there's no net transfer of heat, what do you think? They will have the same temperature or different temperature?
Same temperature.
Same temperature. Okay, so we will see that when the two objects, okay, are in contact and reach a thermal equilibrium, okay, so the rate of the heat transfer from object 1, okay, which means that from the from the hot cat to the cold rabbit, and from the cold rabbit to the hot cat will be the same. So there is no rate of heat transfer already, no rate of heat transfer. But for thermal contact, there is net of heat transfer. Okay, so and in terms, yes. Wait, let me finish it. Let me finish it. So then in thermal equilibrium, there are two situations will happen. One, no net transfer of heat. Two, these both objects will have the same temperature, already. Okay, Ken? Okay, like I want to ask question, ask now.
Teacher.
Yes.
Teacher, what is net? Teacher.
So,
net means that there is a difference in the transferring of heat. Net, means that baki. Okay.
Teacher, so thermal contact is
others,
when there is
others. This one, the one I highlighted here now is your notes number. Now it's notes number what already?
5.
Number 5, huh? Number 5. Okay, like, who wants to ask more questions?
So
number 4. Is it?
Teacher, the one that you explained is the difference between thermal contact and thermal equilibrium, right?
Yes, it's a process. Okay, like I draw over here. I draw over here. Okay. Okay. While you're copying, I explain over here. Okay. Okay. So this is object 1. Okay. This is object 2. Okay. This one is hot. This one is cold. Okay. When these two meet with each other, okay, they meet with each other, they will happen what? Thermal what? Thermal
contact.
Yes, thermal contact. Thermal contact lah.
Sorry.
Thermal
Teacher, how
contact.
do they contact each other? How do they have
They just meet close to each other only. Okay.
Yeah.
Yes.
Teacher, it's like It's like you put ice in water, then
Correct.
you
When you
become
put ice in water, it's also a thermal contact. Okay. Okay, then
Okay.
the hot object, okay, will transfer more heat to the cold object. Okay, the cold object also will transfer heat to the hot object, but it will be lesser. That's why we will say here there is a net transfer of heat.
Heat.
Okay, net transfer of heat. Okay, so they will thermal contact until it reach a situation where we call it as thermal equilibrium. Okay, thermal equilibrium. Okay, thermal equilibrium. Okay, so where in thermal equilibrium, both the object, there is no net transfer of heat, and also both objects will have the same temperature. Okay, get it?
Teacher, can you repeat again?
Where? Repeat from where?
From you draw the thing you draw.
Who is asking? Kyoko, is it?
Jen.
Jen.
Teacher,
Okay.
not me.
Sorry. Jen. Okay, Jen. Jen, you can see my screen here, not the pen here.
Can.
Can. Okay. Okay. So this one is actually like, okay, why is this the two objects? Okay. When the two objects are meeting, okay, why the object, one of the object, it will become cooler, one of the object will become hotter? Because they have thermal contact with each other already. When they have thermal contact with each other, okay, they will be transferring heat from one another. Okay, so hot will transfer the heat to the cold. Okay, cold also will transfer heat to the hot. But just that hot will be more. That's why we will say that there is net. Okay, there is a difference in the net transfer of heat. Okay, so they will transfer heat until it reach a certain level where thermal equilibrium is achieved. Okay, when thermal equilibrium is achieved, which means that both of the objects have the same amount of heat already. Okay, so when they have same amount of heat, will they transfer heat from one another? No more already, because there is no net already, ma. Okay, there is no net already. Okay, so then these two objects, when it reach thermal equilibrium, we will say that both of these have the same temperature because they have the same amount of heat already. And when there's same amount of heat, there will be no net transfer, okay, between the two objects. Can get it, Jen?
Teacher.
Yes.
Teacher, beside the thermal contact, left hand side, you write net transfer heat.
Yes, net transfer of heat.
Okay.
Teacher.
Yes.
The now you show the slide one is the next notes, is it? Like after number 3 is this one.
Hello, this one is number 5
After number
already.
4.
Megan, I will just send the notes to you later, okay?
Teacher.
A.
Teacher.
A.
Okay. After thermal equilibrium, why? Okay, the note, right, for A, they say that the rate of heat transfer from 1 to 2 is equal. So why is there still transfer of heat?
No net, Aga, no net. This one is thermal equilibrium. It's not thermal contact. Thermal contact, yes, they will have transfer of heat, but now here is thermal equilibrium already. You know what's the meaning of equilibrium? Not equilibrium means that
balance,
same,
right?
Balance already.
But then here say that the rate of heat transfer is equal. I thought no more heat transfer, right?
There is also heat transfer, just that the heat will be the same. No net transfer.
Okay.
No net transfer of
Okay.
heat only.
Okay.
Okay? Can
Yeah.
So just now, like what Megan have give the example of the cold water, you put a water. If you want to make it cold, what will you do? What will you do?
Ice
You will
cube.
add in
Ice cube.
Okay, so why the ice cube in the end it will melt? Because the ice cube is gaining the heat from the Water.
Water.
At the same time, the water is giving the heat to the ice. Okay?
Yeah.
Okay. Then, how do I say already?
Teacher.
Hey, yeah.
Teacher.
Yeah.
In this topic, right, we learn the thermal equilibrium in solid, liquid, and gas, is it?
Yes.
Okay.
Okay, can I? Okay. Okay, right? So these are the next, it will be the application of thermal equilibrium. Okay? Okay, so for example, cooking using an oven. Okay, cooking using an oven. Okay, if you put something into an oven, what happens when your bread or everything take out? It will become
hot and cooked.
Become hot and cooked. Why is it so? Because in the oven, okay, is providing the heat, transferring the heat to the object. So until it reach a certain thermal equilibrium, when it reach already, so which means that they have the same temperature as the oven already. So when the object taking out, when the bread taking out is become hot already, no? Okay. Another one, it will be cooling with a refrigerator. Okay, same thing. When you put Coca-Cola into a refrigerator, when you take out, it becomes cold already. Why is it so? Because inside a refrigerator, okay, the Coca-Cola is transferring the heat to the refrigerator until it reaches a certain condition, which is what we call as thermal equilibrium.
Thermal equilibrium.
Yes, thermal equilibrium. So where both the refrigerator and the Coca-Cola will have the same temperature. That's why the Coca-Cola is feel cold. Yes? Okay?
Teacher, then if like if like you put the thing into the freezer, then it become cold.
Correct. Same meaning also lah. It's the same concept. Okay. One more thing is measuring body temperature. So what are you using to measure your body temperature?
Thermometer.
So in last time lah, long time one lah. Okay. So nowadays you are putting your thermometer, your digital thermometer near your ears. That why is it so? Because when you are putting the thermometer near your ear, okay, thermal contact is you will have thermal contact between your ear and the thermometer. Okay. Then the thermometer, okay, will have thermal contact already until you reach a certain condition we call it as thermal equilibrium.
Thermal equilibrium.
Then digital thermometer will be already. That will be your body temperature. Okay, can I? So just like what is over here. Okay, same thing. If you are having fever, okay, so what will your mother do? Your mother sometimes it will soak a small towel, then put around your forehead there. Why? Because the forehead there. Because the wet towel will absorb the heat from your body. Okay, at the same time, your body will feel cooler already. Why? Because thermal equilibrium has achieved. So both the hot towel, okay, and your body will have the same temperature already. Okay, Can?
Okay.
Good.
Can.
Okay.
Can.
Aga, I think I might have a problem already. I don't know why this time my Zoom only allow me to use 40 minutes only. Okay. So now what will
Zoom also 40 minutes when you download
what I will do, what I will do now is I will create a new meeting for you. So once I off this one, okay, you join the meeting in the next one again. Clear? Can?
Okay.
Nah, 45 minutes je for Zoom ni. Tapi Tega will go for another one.